Hi, and welcome to this session about Azure Durable Functions. My name is Stropek, and in the next hour or so, I would like to introduce you to the core concepts of Azure Durable Functions, and we will take a closer look at how durable functions really work, how you program them with .NET Core, and what's going on behind the scenes. I did this session originally yesterday at the Microsoft 365 Virtual Marathon Conference, but this is not the live recording. I decided to re-record it because of the streaming technology that was used for the Virtual Marathon Conference. I had to reduce my screen resolution pretty significantly, and therefore I decided to re-record the session. You will hear exactly the same content, but with a better screen resolution, and I hope that helps if for those of you who would like to follow along, type in the code and try it on your own. It helps us to keep a better overview about what's going on, and therefore I hope that's okay for you. If you would like to get in touch or keep in touch, just visit this website here. You will see a short CV of myself, and in the right lower corner you will also see a lot of links to my social media profiles, to my YouTube channel, and so on. It's a good way to keep in touch. So if you want, just send me a link or send me a tweet, something like this, and we can keep in touch. Good. Without further ado, let's get right into the talk. The talk will be demo. So I have only prepared 2 conceptual slides or so. The rest is code. If you're interested in the code, feel free to grab it from GitHub. I added the link here. You just follow this link and it will bring you to GitHub, clone the repository, and you have all the demo code, the ready-made solution. You find the snippets if you would like to follow along, follow step by step what I do. And there is also a larger version of this demo that even incorporates services like Cosmos DB and so on. Here is the short link that you can use, so if you will have to type it in or want to make a note, this is the link that brings you to these slides, and from these slides you find the GitHub link, you find a link to my YouTube channel, and so on. Good. So let's talk about what we are going to build today. Our example will be a fictitious solution for highway patrol. So what we have is a fictitious gathering, a fictitious collection of traffic cameras, like you see it here. These traffic cameras are IoT devices. They are smart IoT devices. They can recognize if a car is too fast, and if it is too fast, then it sends a speed violation record to an Azure function. We use a regular Azure function for it, and this Azure function receives the date and time when the picture has been taken, the camera ID, things like that, and also with machine learning trained recognition of the license plate of the car. And we also get some quality of the license plate recognition. And if this license plate recognition quality was not good enough, I added a special feature here, and this special feature is operators. You see the operators symbolically here in the right lower corner. The speed violation function has to ask an operator for her help if the license plate recognition was not good enough. And in this case, in this scenario, I'm going to simulate the communication with the operator through a bot. A Slack bot, a Teams bot, any kind of bot that works based on webhook mechanisms. So we can send a message through the bot using an HTTP request, and we will receive the user's answer through a webhook, again, through an HTTP request. The important thing here is that the operators might take a little bit of time, might need a little bit of time to take a look at the pictures. Maybe they get a lot of requests currently, maybe they are on a coffee break. It can take minutes, maybe hours, until they have the time to take a look at the message from the bot. Therefore, we cannot use regular Azure Functions for this purpose. Azure Functions have a pretty strict timeout behavior. They can take milliseconds, seconds, but they should not or must not take many minutes or hours, days, or maybe even run forever. That's simply not possible, because as we know, Azure Functions are serverless computing, and that means that they are scaled down, scaled up, just as needed. Sometimes they are moved entirely from memory. If you would remove the function entirely from memory, and you store some state in memory waiting for the bot's answer, for instance, your state would be gone. And this is exactly where durable functions come in. My goal is not that I show you all possible scenarios, talk about architectures of Azure Functions. My goal in this session is to demonstrate how you program with durable functions and to show you how durable functions do their magic. Without any further ado, let's go right into Visual Studio and create a new project. And in this case, we are going to build an Azure Function project, of course. I prepared a folder here, it's called Durable Life, and I will call it Speed Recognition Sample. Sounds good? Good. The first thing, we have to select our programming environment. Of course, we will use the latest version of Azure Functions, and we will need a trigger. I will not talk about Azure Function basics. I assume that you have a little bit of experience with Azure Functions, so you know about event-driven computing. You maybe know about the different triggers and bindings that are available. In my case, if you think back on what we discussed before, let me bring that up again. We get the original speed violation from our traffic monitoring cameras through an HTTP post. Therefore, it absolutely makes sense to use an HTTP trigger. I'm going to use the storage emulator locally, that's fine, and we are not going to talk about authorization in this talk. This is out of scope for the upcoming minutes. Good, let's create the project. It will take only a few seconds. And now we are here, we have our first function. This function is written as you've seen in .NET Core. So if I click on the project, you will see here that we have a .NET Core app 3.1. Let me quickly bring up Zoom it so I can zoom in a little bit and mark some things here. .NET Core, as you can see it here. So it's a .NET Core 3.1 application, and the function, for those of you who have not that much experience with Azure Functions, it's just a function called run here. In a class, we can remove the static if we want to use things like constructor injection and so on. We can also remove that one if we want to have constructor injection like you are used to in ASP.NET Core. And then we just program the business logic. We can immediately run this example just to make sure that everything's built fine, that everything's work, and it will bring up the function runtime. Again, I assume that you have a little bit of knowledge about Azure Functions. As you can see, this is not ASP.NET Core, this is the Azure Function Runtime, and now we could use the local function runtime to call this URL, send it some post requests. I think you get the idea. That looks good. Good. So let's get going. Of course, I will not write the entire code during my presentation today. What I will do is I will use snippets. And as I told you before, these snippets are available through the GitHub link that I showed you before. And let's get started. Let's get started by adding the first snippet. That's a basic function. That's the first snippet I'm going to use. Oops, you see, I now created nested classes here. That's not a good idea. Good, better like this. And the second snippet that we are going to add is a little bit of data transfer objects. These data transfer objects, let's start with them to get them out of our way because they are really trivial. They are just data classes. I didn't spend very much time to design them and things like that. They just carry some properties for the initial sending of the speed violation, for an approval request that is sent to Slack, and so on and so on. I will not go into the details. You can take a look at it. It's not that interesting for the sake of this demo, so that's fine. As you can see here, we have the class, I called it traffic speed violation. And again, we have a function and we have the function with the name. And the first thing where I would like to draw your attention to is this one. This is a regular Azure function, a short running Azure function as you might already be used to. But in this case, we get an additional parameter injected. It's the durable client with the interface iDurable orchestration client. This durable client allows us, especially the iDurable orchestration client, allows us to trigger durable function, a so-called durable orchestration. It's called orchestration because it's like a conductor in front of an orchestra, orchestrating the different musical pieces and so on. And this durable orchestration does a similar thing. It starts something here, then waits a little bit, and when something comes back, it starts something here. So it's orchestrating the whole process. That's the idea of this iDurable orchestration client. We can start this orchestration using this client. Obviously, it is not yet in our project, so we need to install a NuGet package for that. That's simple because Visual Studio automatically suggests a meaningful NuGet package, Microsoft Azure Web Jobs Extensions Durable Task. That sounds good. Let's find and install the latest version, and then the red squigglies should go away. Now we have the necessary SDK pulled in, and it will allow us to start the orchestration from our regular function. Last but not least, I have to change a little bit here in the usings, because in this example I decided to really go with the new JSON support in .NET Core 3.1. We are no longer using Newtonsoft.json here. I'm using the system.text.json serializer, and this serializer will get the requests content. Let's quickly go back here. This is the camera. It sends some HTTP content to our function. It deserializes the body of this HTTP request and makes a speed violation data class from it. Yeah, then we see log error, not yet implemented. Looks good. We will just return status code OK. So let me run this guy. It should come up in a second. Let's stop it again, rebuild it, and hopefully now it will work. Yes. And here we are. That looks pretty good. Let me now open up my durable function folder here in Visual Studio Code, because I've prepared a bunch of requests, and this will be a typical sample request that comes from a traffic monitoring camera. You see the license plate, the recognition accuracy, the speed, and the camera ID. Let's send the request here, and we will get a 200 OK. And if we take a look here, we see the error message that the function is not yet implemented. So everything looks good. We have our skeleton projects set up, and we can start implementing code. The first thing is I will add a little bit of code here in our regular function. Let's use the next snippet. Here we will call a helper function store speed violation if the recognition accuracy is good enough. And this helper function, let's quickly add it here. I've also a snippet for that. That's this one here. This helper function in practice would probably write the speed violation into a kind of data store. Maybe Azure Storage, Azure Cosmos DB, a SQL database, a MySQL database, something like that in Azure. In our case, I'm just simulating writing the data to a database. We're just printing out some log data, and at the end, yeah, nothing special. We will just return a completed task. So this is just a simulation. Use your imagination here. Here you had your arbitrary complex code accessing any kind of data storage mechanism that you can think of. For now, that's perfectly fine, and we'll take a look at the code again. If we have a recognition accuracy lower than 75%, we will log some information, because here, exactly here, we have to add the code where we use the long-running orchestration, talking to Slack in the background, using the bot to ask an operator for help. This is the area that will become pretty interesting. The usual case, if the recognition accuracy is okay, is not that interesting for this demo, because that will be a usual function running in this area, just storing the speed violation. It will finish within a bunch of milliseconds and we're done. So we'll focus on that one. And I made a mental note here that I have to change my host.json file, because I want to see the log level information in my logs, and I've done that here. That looks good. If you're not familiar with logging and log configuration in functions, follow this link. It's part of my snippets. That sounds good. I think we don't need to run this example because nothing special here yet. We have to use the next snippets. We have to add a little bit of advanced functionality here. So, good. This is our regular function, and now we are going to add here another class, here, this one, and let's call it our speed violation orchestration. I will remove the class because I have a snippet for that, but we have a new folder, a new file. So we have here, oh, function 1, that doesn't look good. That's the HTTP API. Let's put it that way. In the HTTP API, we have all the Azure functions which are triggered by HTTP requests, because we are, if I go back here, talking to the cameras using HTTP, talking to the Slack bot using HTTP requests. We will receive responses from Slack using webhooks, meaning HTTP request. So in our case, we are really using a lot this HTTP trigger. So this is in the HTTP API. And here we have the orchestration function. Let's add the basic orchestration function here. It's not finished yet. Let me get rid of all these red squigglies. We have to, here we are, add, which is that one. Oh, I didn't insert that one. We will add that in a second. First, let me add all the necessary usings. That looks good. Now we have here the iLogger. That should be extensions logging. And last but not least, we will need, which is this one, manually, oh, it should be here, manually approve recognition. Oh, I forgot the class. Oh, I'm sorry. Let's call this speed violation orchestration. I have deleted a little bit too much code, but that's fine. It's a leftover. Okay, that looks good. Put it as a public class here, and that sounds pretty good. Okay, now as you can see, let me move that one here so you can see everything. This is, again, a function. It has a function name, as you can see it here. By the way, I always use the C# name of functionality to specify function names. Of course, I could specify a string constant here too, but using the name of operator in C# makes it much more maintainable. I don't have a stringly typed API, I have a strongly typed API, so I definitely prefer the name of function here. This manually approve recognition is not triggered by HTTP, but this is now an orchestration function. This is a function which is a durable function, and it is triggered by the iDurable orchestration client, which we had exactly here. You see, this one triggers an orchestration function, and this orchestration function gets the context of the orchestration here in the first parameter. Let's make it like this, then it looks nice. Now what does this function do? First, it prints a little bit of information here, log information. You know what? I will say warning, just that we see it better in the log file. It's not really a warning, it's just a log message that I write out to understand, get a better understanding how this stuff works. But warning will make it scream out of the log, so that's much easier to see and recognize. We get some input here. This input, speed violation, this is the input that we get when we will call here the orchestration with our orchestration client. And you know what? I will immediately add this code because that will give you a better idea, a better understanding of how this triggering works. As you can see it here, manually approve recognition. That is, of course, we need to add the class name here, here, because I've put it into a separate, oh, you know what? Let's put it in the same class. That makes it even better. Partial. I just decided to change my demo script and make it a partial class, because then the code is much simpler and easier to read because I don't need to specify the class names. I hope that's okay. So here you see we are starting a new orchestration and we are using the starter parameter here. This is the orchestration client. And then we can here pass in some payload. SV is the speed violation which we got from the camera. So we are passing in the data that we got from the camera and ask the orchestrator function to do the long-running orchestration for us. Then we will return a check status response, and we will see in a few minutes what this check status response is all about. Please bear with me, you will learn about that in a few minutes. Back to the orchestration function. The orchestration function now extracts the speed violation data, which was the payload when starting the orchestration, into a local variable. And then it should talk to Slack. Yet it doesn't talk to Slack. It doesn't talk with it isn't a bot yet. It doesn't send a message using HTTP. So this message here has not yet been implemented, but we have something else here. What I've already added to this level of the snippet is I added timeout. As you can see it here, I'm using really regular C# code. I'm awaiting a task. I'm using a cancellation token source. I'm using a timer in that area. So I'm doing regular C# programming with async await and things like that. The big difference, and I would like you to note that, is that I'm not, for instance, here using datetime.now. Instead, I use a helper function from the durable function API, context UTC datetime. Additionally, I do not create a regular .NET timer. I again use the durable function API to create the timer. Here, this await really just awaits a regular task, but the difference is that the task that we are awaiting here can be a really long-running task. It can run for minutes, hours, days, nearly forever. And the durable function runtime will make sure that this await here is capable of handling even long-running waiting periods. At the end, I'm just cleaning up. I have to clean up the timeout task, which is just this durable functions timer, and then I am done. Now, why is it important that I use context.currentUTC_datetime in that area? It is important to use current UTC datetime because you have to understand that the durable function API works like this. It starts the function the first time it is called from the very beginning, so it executes. Then at a certain point in the execution cycle, the system is awaiting something, and this await here on the right-hand side can be a pretty long-running task. So imagine the following situation. We are awaiting the timeout task. Okay, I have here add seconds 10, but I could specify here add minutes 180 if I want to wait for 3 hours, for instance. Then of course, this await cannot lock everything in memory. It could happen within these 3 hours that our entire function goes out of memory because maybe all the servers are removed. We are scaled down to 0. How can the system correctly continue logically from here? The answer is it doesn't. It starts the function the next time you call it again from the beginning. But when you use functions here from the durable functions API, these functions will not execute the business logic again, but they will take a look into storage. I will show you how they do it in a second. They will take a look in Azure storage in a special Azure table store and look whether this orchestration function has already been executed and has already run over this line of code. If it did, the original value of the UTC datetime is going to be returned. So it's no problem to start technically again from the beginning because you are essentially replaying within a bunch of milliseconds everything that has happened before the await. And from here on, logically, everything starts to run again. So if we have another await and another await and another await, the whole process starts again. So you can say that an orchestration function is replayed again and again and again by recognizing which operations were already running in previous executions of the function, and the runtime only executes those asynchronous functions, or those functions, let's make it more generic, that have not run yet already. Okay? And I can show you that this really works. Let me do the following. Let me put Visual Studio here on the right-hand side, and then, let's put it this way, run the application, and let's put the log here on the left-hand side. Oh, I need Visual Studio Code here on the right-hand side, sorry. Now let's send a new request. The camera is taking a picture. Boom. It's 0.6 and you see, communication with Slack is not yet implemented, entering manually approve recognition 12:59:48. So now I'm not touching the keyboard at all. And after approximately 10-12 seconds, the whole process runs again. You see it here? And you see the log message appearing again. So you see that, and now let me move it here. You see this log message here. You can find it one time in the log and you can find it a second time in the log, although it's only once inside the code base. The reason for that is because the replay mechanism started the function after the timeout. It started the function from the beginning, and as you can see, approximately 10 seconds, a little bit more than 10 seconds, that's perfectly fine. You cannot say exactly how many seconds it will take. It's an approximation. And how does the system know what has already run? The answer can be found in Azure Storage. So let me refresh these two tables here. Here they are. Here in the test hub name instances, you see all the instances of our durable function. You see the payload with which this function was called. And here you see the different steps that were executed. And if you take a very close look here, you will see here in the timestamps that we had exactly here the break. So the system wrote the status of the durable function here in this table storage, and afterwards, after continuing after 10 seconds, it wrote the next steps step by step until the orchestrator completed, because our entire orchestration functions ran to an end. So this is how durable functions work in the background. They store the state in Azure Storage. Sounds good? Fair? Good. Let's stop the debugger and continue. Let's elaborate our functionality a little bit more. So now I'm going to here implement the communication with Slack. If you implement a Slack bot, I'm a little bit familiar with Slack bots, not so much with Teams, so I will just say Slack, but I'm sure you can implement the same thing with Teams here. If you would like to display a message in a Slack channel for an operator, for instance, you have to send the message using JSON and HTTP. You have a special HTTP endpoint, you send an HTTP post to it, and that will result in displaying a message in a channel in Slack. If you give the user a selection, approve or decline, and the user presses approve, again, another HTTP request comes back from Slack into your application. Not the database, of course. There is some business logic here. We have to add some functions in this area, but you get the idea. If we get the approval back, we write it into the database. Good. Let's add the necessary code. Let's remove these two lines here and add a small snippet here. We already had that one. Send approval request. Oh, that's the wrong snippet. I have to add first the function doing really the call. So we have to say this one. We'll take a look at this code in a second. And this is the next snippet. So trigger approval request. Now let's take a look at the code. This here, what you see here, is just another function, but it's a third type of function. We had the regular function, short running. We had the orchestrator function, which is a long running, durable process. And now we have an activity. An activity is something that you can trigger inside an orchestration function. And all the rules apply that I told you before. So if you trigger an activity and the whole replay mechanism triggers on, it will not call your activity again and again and again every time the durable function starts from the beginning, but it will remember that it already triggered the activity and just read the previous result from the previous call to this activity. In this case, I call the activity send approval request via Slack. It gets some data transfer object called approval request. And here you have again to use your imagination. Because of the sake of time, I will not implement the communication with Slack. By the way, in my GitHub repository, you will find a larger example where I have really implemented the communication with Slack. But for this demo, just use your imagination. Here we would call Slack as soon as it makes sense. This send approval request will return nothing because Slack will not return anything. It's an asynchronous process. Slack will come back with a separate webhook later on so that we have to receive the webhook asynchronously. Now, how do we trigger this request here? I have to zoom out a little bit so you see it better. Up here, you see the call of the activity, call activity async. Here you see the connection between our activity and our durable function, our orchestration function. And here you see that we pass in some payload, which the approval request via Slack functionality, this activity, can work with. This is what we do. So we are calling the activity. Yet we are currently not waiting for the response. What we need to change here is we need to change this code so that it does not only wait for the timeout, but it should wait on the one hand side for the timeout, and on the other hand side, it should wait for a response from Slack. And it should continue if either of these two return something. So we can use a classical C# mechanism, which is called task.whenAny. That's a task parallel library. And you see, that's the beauty of durable functions. You can use the same C# programming model that you are used to in C#. You can do all the crazy stuff that you can do with async programming. You can do things in parallel, asynchronously. You can wait, you can fork, you can join. All the things are possible here in durable functions. So let's make this a little bit smarter and add the necessary code. This was the approval request, and this is the approval. No, again, wrong snippet. I'm sorry. I have so many snippets. I forgot the order. This is what I want to have. This is what I want to have. We are using a functionality from durable functions here, which is called wait for external event. Wait for external event just puts the durable function, the orchestration functions, to sleep. Well, to be technically more correct, it does not put it to sleep. It returns, if you take a look here, a task, and you can await the task to put the orchestration function to sleep. It waits for an event, and this event has a name. I told you already that I don't like string magic strings, so in my case I will not just write the string constant here, but I really like to add a string constant in code. You see this one, and whenever I need the name of this event, I will again use the name of functionality. You see it here, or sorry, in this case I'm referencing a string constant, so this is what I do here. So now let's analyze this code a little bit. You see, we have the timer, which gives us a timeout task. We have the wait for external event, which gives us an approval response task. And now I can use the regular C# API task.whenAny to continue with my long-running process if either the approval response from Slack comes in or the timeout task fires. So as a C# developer, you will love this, because you can finally program workflows, if you want, in C#, in the language that you know and probably love. One question comes in. Who is triggering this external event? Who will trigger this event? The answer can be found in my slides here. It will be triggered by Slack. It will be triggered by Slack sending an HTTP request. Will we handle this HTTP request directly? No, of course not. What we will do is we will go back to our HTTP API and add a function that acts as an endpoint for Slack to receive this method. Sorry, this one. And I called it, let's see, handle Slack, process Slack approval. That's it. That is now a regular HTTP triggered function, just like we had it before. Again, we take the iDurable orchestration client. The big difference is that this function now will not start a new durable function. What it will do, it will get in some way, Slack will store some state and will send us back an ID of our durable function, and this ID we can take to get the status of a running orchestration. In this case, I take the orchestration ID that is round-tripped through Slack, get the status of the running task, of the running orchestration, and I can raise the event. This raise event here is going to trigger our event. So they belong together. So what we do again here, just so you understand it, we are round tripping the ID of the orchestration function through Slack, through the bot, back to our regular function again. And this regular function, again, picks up the ID, looks for the running orchestration function, for the running durable task, and raises an event. And this raise event will go here and make sure that our function is continued at that point. Good? Let's give it a try. Let's see whether this really works. And finally, by the way, we are storing the speed violation on the screen. And just to make sure that everything is fine, we take a look at this function again. Oh, and I see that I forgot something. You see that one? Store speed violation. We called that before, store speed violation. We call it here in our regular function. But this time, I would like here to call it as an activity. So we somehow have to make our existing functionality, store speed violation, just a helper function, into an activity. Luckily, that's absolutely not complex. I can add here another snippet, this one, and you see the difference? Now the only differences are, on the one hand side, the function name attribute, and on the other hand, the activity trigger. Everything else remains exactly the same. This is how we turn a helper function receiving the speed violation and a logger into an activity which can not only be called by a regular function, but it can now also be activated as an activity from an orchestration function. Now it should look good, and you know what? I will again change that to a log warning so that it will display a more easier to spot line in the log. And we no longer need this warning because we are no longer looking for that one. We are looking for the other one. That's now important. Okay. And I will add the timeout so that I can be a little bit more slow when doing the demo. Let's trigger the functionality, and let's put the functionality here on the left-hand side, make it a little bit smaller. Let's add our REST client here on the left-hand side. That looks good. And yeah, make it a little bit smaller. I think that's okay. So what we see here, speed violation recognition, this one is the camera picture. Let's send it. That will trigger our long-running function, and you can see here we get a bunch of status get query IDs, and this is the ID of the orchestration function, and now we can send this ID. You see, we are now simulating the response from Slack. By sending this ID back to our regular function with approved true, we continued our long-running function, and at the end we finally see that one, processing speed violation, we finally wrote everything into our database. That is what we wanted to do here. If I don't respond in time, we should get a timeout. Let's try that. I will start a new workflow, and while we are waiting for the timeout to trigger in, I would like to quickly talk about this one. This was the status request that I was talking earlier about. Here you see you have different URLs with which you can take a look at the status of the long-running process. You can send an event there. We just sent an event. You can terminate the process. And by the way, did you see it on the left-hand side? The timeout was here. So we did not write the recognition into our database because we had a timeout. Maybe in real life we would write the speed violation into some kind of administrative queue so that an administrator can take a look at, but everything worked nicely, the timeout worked, and if we are fast enough, the approval worked. Yeah, and from the first scheduling of the orchestrator, as I told you, you get a bunch of information here that gives you an REST API with which you can interact with your long-running function. I will show it again to you. Send a request. Now the long-running function is waiting. Take the ID, you see it here, and send the confirmation, and Slack has responded. Everything is written to the database. So works pretty nicely. If I now take a look at the status URL, I take it here, then you will see, if I take a look here, see it? Completed. That's good. If I'm faster, run this one. See, running. Let's wait for a few more seconds until our timeout kicks in. It's still running. See it here? Let's wait a few more seconds. It should be done. I think I have 20 seconds timeout. So timeout should be visible any second. Here is the timeout. If I run again, you see it was completed. I can also add some output data, some custom status data, and so on. So there is a lot of possibilities in the API. You can take a look at it by looking at the documentation. So that looks pretty good. We have achieved quite a lot here. Okay, so we have our API on this side and we have our orchestration on the other side. The state management in my example is essentially done by the durable functions runtime. We store it seemingly in local variables. For instance here, the original payload, the speed violation, is stored in a local variable on the stack, but not really. You now have a deeper understanding where it is stored in reality. In reality, all these local variables are, you can see it here, they are stored inside of table storage. And because these durable functions start again from scratch over and over again, this get input will not every time require to resend the data, but it will recognize that it is a replay run and get the original data, the triggering data from Azure Storage. Good. Very nice. The next thing that I would like to show you, and this will be my last demo for today, is a different kind of programming model. This programming model is called durable entities. It's newer, it's younger, and it solves a similar purpose as durable functions, but it is just another programming model. With durable functions, it is easier to have some kind of central location, a thing that has a reference, an ID, a record in a database if you want. And then over time, over a longer period of time, you are going to collect data from different sources. For instance, when the operator says, okay, this is really a speed violation, we can initiate a lawsuit. And after a few days, the police will send some data and set the driver for the lawsuit. Then a judge will do its job and set a fine for the speed violation. And after another few days, the violator will pay the fine and the fine can be marked as paid. And all these calls that happen over quite a long time, can be minutes, hours, days, weeks, they are gathered in a central data record which has a primary key and ID. They are gathered here. So all we have to do is we have to offer the necessary functionality here, provide the business logic for setting this stuff, but we do not have to store these entities in a durable way in our own databases. This is what we will take a look here in the last few minutes of our demo. Good. So let's add the first class here. Let's call it the lawsuit class. And I have prepared another snippet for adding the lawsuit here. We have this one, exactly that one. Now let's take a quick look into this class. Oh, let's get rid of this red squigglies by adding the necessary using here. This is a durable entity. It contains the original speed violation data, and then it collects the data which is gathered over time. This is what comes in regarding this speed violation up here over time. So initially, driver is null, fine is null, paid is null. And then we can add some functions with some business logic through which these properties can be manipulated. Set speed violation, store driver, set fine, and I think down here I also have a mark as paid, and I also added a delete function. Then we have, inside our durable entity here, we have another function. And this function has a new trigger, not an activity, not an orchestration, not HTTP, but this time it is an entity trigger. So this function runs whenever we create a new instance of a durable entity. We can add some initialization code here, this one, and then just return a kind of identity of our durable entity. I'm using here the class-based API. There is also an API, a programming model where you don't need to create a C# class, but if you are in an object-oriented language like C#, a class is really a natural fit for a durable entity. So I really like this programming model. If you want to take a look at the other possible programming models, please take a look at the documentation. So we have our lawsuit here. Now we need to trigger to create a lawsuit durable entity inside of our orchestration function. So if we go here, currently we are just calling the store speed violation, but here I will add additional code that creates the durable entity. Here it is. This code that you see here, this one, is now creating, let's add the necessary using, it's creating a durable entity and calls the set speed violation. Let's quickly go here. This is the speed violation that this entity is representing. What we get back is an entity ID, which represents the entity in a durable way. So over time, we can always find the lawsuit using this ID. So we have to make sure that we need to write this ID somehow and give this identity, this ID back to the caller. So what we essentially can do is we can say context dot set custom status. This is a status that we can append to our durable function, not entity, and we will just say please add the lawsuit ID to string. So we will return the ID of the lawsuit back to the caller. Okay? Now we have a durable function, a durable entity, I'm sorry. Now how can we interact with this durable function through these methods? The police, for instance, they have their own, let's say, IT system, and this IT system would like to talk to our durable entity. We don't want to expose that we are using durable entities, so therefore we will give them a specialized HTTP-based API, and this HTTP-based API will then use the durable entity SDK to find the durable entity and update it. The same is true for setFine, the same is true for marks paid. In this demo, I will just implement the setDriver method because that's the interesting thing, getting an understanding of the basic principles. The other things, they are just working in exactly the same way. So let's go to the HTTP API here and add another function. Oh yes, here I have. Finally, I found it. Sorry. This is the API. I did name the snippet very poorly, but yeah, it's fine. So you see, this function setDriver is an HTTP triggered function. So this is the function that the police's operational system is calling inside our system. And one import here is the driver name. This is the payload that we get in. And from the URL, you see it here, lawsuit/entity key, we get the ID of the durable entity. And then we just send a signal to our entity and would tell it to call the store driver method with this payload. If we take a look here at the lawsuit, you will see we have a store driver method which takes a string, which is the driver, and updates the driver property accordingly. Now the durable function API in the background will JSON serialize the content of this speed violation lawsuit and write it to the underlying Azure storage, to the table storage. So it always has the current situation, the current values of the properties stored in Azure storage. So we do not need to manually create database, write to this database, do some updates, inserts, delete. That's absolutely not possible. We just pick up the entity, the durable entity, send it a signal to call the necessary function, and that's it. That's all we have to do. Let's give it a try. That's the last demo that I would like to show you. Good. Let's run the speed recognition sample here. And again, let's go here onto our sample requests. Okay. Now we have the camera and it picks up an image of a speed violation. Yes, it looks good. So in Slack, we click on approve. This is that one. And finally, it is written to the database. Okay? If we take a look at the status of our current process, the process is completed. But what we got, you see it here, we got an ID. See it here? An ID for our speed violation lawsuit. Okay? Now, if we call this response here, we execute it, and now we have updated here the lawsuit. So now we have set the driver of the lawsuit, and let me take a look here. You see the driver is foobar. With this get method, let me make that larger so you can see it better. With the get method here, this one, we can take a look at the status of the current lawsuit. It's now foobar, and with this post request, we call our method, this one, setDriver. This setDriver picks up the durable entity, sends it a signal, and updates the driver data accordingly. So now we have a sample that goes through the entire technology stack of durable functions. We take classical functions, HTTP triggered function as a kind of, let's say, REST-ish API onto the front. Let's go back to the slide so I can show it to you better. So we have a kind of REST-ish API here for the cameras, here for Slack, and finally here to our external systems. Internally, we do not need to maintain state, because in the durable function, we can store the state of our local variables implicitly, because that is done by the Azure storage system and the Azure durable functions. And in this case, with the durable entities, we also store the current status of our lawsuit, and we do not need to do that ourselves, but this is again done by the durable functions runtime. This is essentially what I wanted to show you. I wanted to show you how this whole stuff works, how the code looks like, how it feels, how you approach problems like that. Take a look at the documentation. You can find a lot of information there. If you find it interesting what you saw here, recap what I did by going through the snippets. Here you see the link to GitHub. I will show it to you. Here you find the snippets. Here you find the ready-made solution. And here you find the HTTP requests that I was showing you in order to demo everything. All you need is Visual Studio with the Azure SDK. You need in the background also Visual Studio Code with the REST client, and then you're ready to go and you can try everything on your own. I will publish this video in my YouTube channel. There are a lot more videos in my YouTube channel, so take a look at it. I hope you enjoyed this approximately an hour, and you got a closer insight, a deeper insight into Azure Functions. Thank you for watching, and enjoy the rest of the day. Goodbye.